Welcome to Rocket Ship, the podcast where web developers learn the skills and secrets to ship awesome mobile apps. I'm Simon Grimm, creator of Galaxies.dev, and super excited because we finally have Marc Rousavy on the podcast. Marc, thanks for joining me.
Thanks for having me. I'm excited for this.
Yeah, we tried to get an appointment for weeks or month in advance, and you've been working on been working on Vision Camera 3. So that's a big part of what we're going to talk about. Quick TLDR about you. You're the creator of some really epic React Native packages. I think I won't count them all. I just found 2 additional ones, but the biggest are probably React Native Vision Camera, React Native MMKV. And then there are some other packages like Graph or Big Numbers. We can probably touch that later. And next to that, you're also the CEO of a company called Margelo, which is an elite app development agency with, I think, 12 employees.
Yeah, we're a team of 12 people, yeah.
Yeah, and by the way, you're only 23. So congrats on all the accomplishments you have done in your life and for the community. And
Thank you.
I think we actually had the same dream of becoming a game developer when we were younger. I heard you say that.
Yeah, I did. I watched a lot of game development blogs and everything. So I had that dream at one point.
So why did we end up here and not in game development?
I don't know. Why did you ever change your mind, or did you try to get into game development?
I think people quickly told me that game development won't really pay well, and you have to work 80 hours per week or something. I don't know. What scared you away?
I don't know. It wasn't really the pay, I think, because it was never really about the pay for me in development. But I think it was just way too steep to get into design and everything, because at that point I wasn't really good at design and drawing models and textures and everything. So I did do a little bit of OpenGL a long time ago, and then that was too complicated for me because I was I think 16, 17 or something. I was like, fucking no, I can't do this. And then I tried to get into Unity, and Unity was, I don't know, it felt boring for me, to be honest. It was just this big suite of a ton of tools and a ton of things you can do there, but it wasn't really clear what I was going to do. So I did I don't know what it was, a tactical maze type of style game, and then that's it. I dropped it there.
And did you, after the Unity experience, went straight into React Native, or did you start with something else in between?
So I think at that time I was working in a more corporate style company, using C# and writing some business applications mail filters or something like that, just boring ass stuff.
So much fun.
Yeah, so much fun. But it was, it was a part-time job next to school, and I was kind of skipping school to work because I thought it was kind of fun, kind of boring. But at some points, I had a really cool boss there. So he's a shout out to Marcus. So he was a really cool guy. And yeah, at some point I was just bored of C# and wanted to try something different. At that point I was a paramedic as my main job for just a civil service year you have to do. And then I basically decided to get into app development because I always wanted to build apps, mobile apps. And I actually started with a camera app, but native iOS. So I built a UIKit Swift app. That failed, so I didn't really know how to work with cameras back then. It was just way too early for AR stuff. I think then I was like, okay, I want to build something cross-platform and maybe a bit easier than native iOS development. So I Googled cross-platform frameworks, and React Native was luckily number 1 in the specific blog post that I read compared to Flutter.
What year was that?
That was I think 2018 or 19.
Okay, yeah.
So not so long ago. And then I think 2019. So yeah, I read this blog post, and React Native was number 1 there, and Flutter was number 2, I think. So I was like, okay, let's try React Native. And now I'm here.
Yeah, that definitely also explains your long-standing love for camera applications.
Yes.
So that's and also your background in C#. I think I never touched C#. I actually did C++ when I was younger.
Yeah, same.
And you said you didn't have the skills for the UI development stuff. Me neither. But I built like a not a CLI game, but it rendered in this like console window, and I built like a little Pokemon game, so I could move. Yeah, ASCII game, right? And I could like with my arrows, I could move. I built like little levels. Here's grass, there's stone, and then you had to fight against Pokemon, and because I pretty much just copy pasted code. I don't actually know. Was there like Stack Overflow back then? I can't remember, but basically on every move of my player ASCII art, I had to redraw the complete view. So when you like were walking, it was like redraw the whole time. It hurt my eyes a bit, but I was probably also 15, so I couldn't find a better way to handle that. But it was fun.
I was actually about to say, like, ASCII drawing gotta be like really slow, right? Because in OpenGL you can draw really fast, but re-rendering the entire console that's just gotta be slow.
Yeah, but like I was fine. I was happy about myself creating this little game. I actually don't know why I did it, and I can't find it. That's so sad.
But it sounds cool. It sounds fun.
Yeah, it was definitely at that time, and it got me started. So, you got in touch.
I actually also did C++ before the C# part. So the first big project, or the first open source project I did, or the first bigger open source project I did, was actually a C++ neural network implementation. So that was one thing that was like technically challenging for me and technically interesting, and I spent a lot of like many weeks on building this thing, because it was like really tricky to do with just pure C++ without TensorFlow or anything. But yeah, eventually I actually published that to GitHub. So that's a really, really cool library.
So in 2019 or something, is it like you got the first time in touch with React Native in about 2019, and 4 years later you have a successful agency? That's like a very, very steep career. How did that like the whole agency thing got started, and how did you get like the first epic project? Because I've seen some of your stories, and they really like, you gotta check this out. I'm gonna put this in the show notes. Margelo has developed some really epic apps. Like how did all of this start?
Thank you. It was, I don't know. So I think the benefit we had, or at least me and my team, is that we all kind of come from a native background. So many of our teammates like have C++ experience, or native iOS like Swift or Objective-C experience, or Java for Android. And kind of understanding your abstraction makes using the abstraction easier, right? So if you understand how React Native works, you have a way better time, using React Native. So I guess that's why we were so good, or are so good at using React Native. And we just kind of built a network there, I published a lot of stuff about my camera, about the React Native MMKV library. Then I did the graph thing with Skia. And you the cool thing about React Native is that you know everybody in this space, right? So you're like good friends with, I don't know, like William Candelan, or Christian Falk, or some other amazing people, so you're just, you kind of know them, you reach out to them from time to time. And yeah, there's just, with a big network, there comes, great opportunities, I would say.
It's really fascinating to me. So, as I said before recording, my background is in capacitor, Cordova, Ionic, cross-platform development, which is, compared to React Native, a lot smaller. But it's so strange. Like when I got into React Native land, and now I had a podcast with a few people, it feels like everyone knows everyone. Like I talked to Catalin Miron, and he knows this person and that, and everyone's recommending Fernando Rojo, and then I talked with Nate from Tamagui, and like everyone, like it's a big community, but at the same time also very small, right?
Yeah, it feels like like a family almost. Everybody knows each other.
Yeah, it's definitely a very welcoming place. So for everyone who wants to get into it, I can highly recommend it.
Is that not the case with the Ionic community?
It's a very welcoming community as well, but it's a smaller community, so there's at the moment not that much going on compared to React Native. If you look on social media, the only thing you're gonna see is Flutter versus React Native, and nobody's talking about capacitor. I have a TweetDeck or something open, so I monitor capacitor as well. And people start noticing it. I don't know if it will take off in a few years because it's still very fresh. But yeah, capacitor, in my eyes, it's a bit better way to have like 100% code reuse. So you can basically build a web application, drop in capacitor, and then it can wrap your app into a native container, and you can still access native camera stuff, because camera is the most important thing.
Yeah.
So yeah, but React Native has some advantages, capacitor has some advantages, and I don't know. Nobody will win. I think all will just coexist. And Flutter is also like good for something. I don't know. Have you done some Flutter?
I wanted to do some Flutter. Yes. I don't know. I found Flutter apps to be poorer in quality because you're just not using the native UI kit views. But in a case where you don't want to use the native UI kit views, for example, I don't know, you have a very opinionated or very, I guess, out of the tree UI system. For example, my BMW app, they use Flutter, I think. So in this case, it makes sense because you're not using any UI like native UI components, but instead you have your own like BMW style components, and it all looks like the car infotainment, but on your phone. So I guess in this case, it kind of makes sense. You can still feel that the scroll views are a bit janky, and it doesn't feel like the native iOS scroll views, but it all looks like the BMW app, and you have like I think 100% platform code share usage. I mean, you theoretically also have that in React Native, but I think there's just more differences because of the two separate implementations, right? Two separate UI systems.
Yeah,
whereas in Flutter you only have one. Yeah.
I think Theo, the popular streamer, recently also talked about Flutter, and he said like there's a very small gap somewhere where Flutter apps fit in. Like you got Unity for games, and you got React Native for everything else, and then you got like a very tiny niche where Flutter makes sense. I mean. He's very famous for not liking Flutter, so take that with a grain of salt. But yeah, I don't know. I think React Native, it just makes sense in a lot of cases as the web world was just gravitating towards React. And I come from an Angular background, so yeah, I'm still a bit sad that Angular did not win, because Angular is also very beautiful. It's actually coming back this year. Have you tried Angular in the latest Angular versions? It's making a comeback.
What did they have any new like groundbreaking features, or
yeah, they're also adopting signals, and they're adopting
oh yeah, I heard about that.
the latest stuff. Like it's making progress, while React is just talking about React server components, I think. And I don't know, it feels like the whole community has been talking about it for months or years now. And meanwhile, I don't really see a huge benefit in React server components if I want to do native mobile apps. Or am I missing something here?
Yeah, no, I think that's not for mobile apps. But I think one exciting React feature that not a lot of people are talking about right now is React Forget. The I guess compiler or optimizer from Facebook Labs or Facebook Experimental that they actually I guess teased a while ago at, I don't remember where it was. I think it was either a conference or just a tweet or something. But it's a really interesting theory where you don't need to memoize anything anymore, right? You don't need to use Memo or React Memo because everything is just, I guess, optimized by the compiler to, check for identity equality or versus reference equality on, some object changes or array changes. I'm not sure if I don't think there's a working or a public version right now, but it seems like this could really be interesting.
That's interesting. Yeah, I never heard about it, but I just looked it up, and they talked about it at ReactConf 2021. And there's a video, React without Memo. That would actually be something really good for me, because I still don't completely get how you use Memo and use callback work, and if I should use it sometimes or if I should not use it. I mean, you're the performance guy. How can I, in the best way, measure the difference? Like, if I create a blank Expo application and I drop in some stuff, and I want to compare if this would work better with use Memo, what's the right way to debug that or see like the FPS, or what's the way to actually check if I made progress on my code?
So there's multiple ways to profile performance. There's, first of all, like three. I guess you can say three major components to performance measuring. One is CPU, which is like, I don't know, CPU usage, or I guess time it takes for a specific function or for rendering or blah blah blah. Then there's RAM to measure how efficient your memory usage is, and if you have any memory leaks. And then there's like GPU usage if you do some I don't know, rendering, camera stuff, Skia stuff, to just kind of measure, are you efficiently uploading stuff to the GPU, blah blah blah. But that's more advanced. So for CPU stuff, I think you can use stuff like React. Why did you render? That's like a plugin for React, or for, I don't think there's a Flipper plugin for that, but it's a plugin for React which you can use to print to the console why a component just re-rendered. That's how you can like actually profile re-renders on the go, and to actually measure time it takes for a function to render or to submit to the React DOM or React tree or whatever, or to create the shadow nodes. You need to create a flame graph profile from your JS code. I think there's a Chrome plugin and a Flipper plugin for that. So you can record a flame graph, do your action, like, I don't know, open a separate screen, which feels slow, and then stop recording the flame graph. And then you can take a look at the flame graph itself, zoom in, zoom out, and see which functions are actually slow and which functions are fast. So that's something we do at Margelo as well. We do lots of performance optimizations for clients. And often it's like really simple stuff. Like, making sure something is memoized properly, something is efficiently calculated. We don't have any unnecessary use state. Sometimes people use state when they should have used use ref. And often it's also some really complex stuff, like, I don't know, a crypto app uses some encryption algorithms, and we need to move those either to C++ code, to a Rust library, make them asynchronous, or run them in a web browser or whatever. Just so that they don't, that they're not as slow as they are currently in JavaScript, for example. So yeah, we do lots of advanced stuff there as well. We sometimes even need GPU profiling to make sure something is rendering really fast, and it often goes into like it's into much detail, I guess.
Yeah, I guess that's definitely something I need to improve. I mean, the Expo team is also working on improving debugging, so I hope it will be easier for people like me in the future. But I want to bring this back to your Epic packages, of which let's start with probably, I mean, this is, I think, the first package you actually used, which is MMKV. Could you describe quickly what MMKV is and why I need it?
MMKV is the perfect solution for your React Native app if you need to quickly cache some values, such as probably user defaults, or like settings or configurations or an auth token, something like that. So just small values that just need to either you write a lot of times or you need to retrieve really, really fast. And that's why MMKV is synchronous. So you don't need to do a wait or need to like have a loading state or something, because you can just quickly get it. It is an in-memory database. That's what MMKV stands for, memory map key value.
Finally someone tells me.
So yeah, it's a really fast user defaults storage. You should not use it for storing lots of data. So you should not use it for, I don't know, a huge user database or like lots of like image binary cache or something like that. That's just going to explode your RAM usage because it is an in-memory key value storage. So yeah. And it uses JSI with a C++ implementation, so it's really fast.
Yeah, your documentation say it's based on Tencent MMKV. I think this is what's the app behind this? I forgot it.
I don't know where they WeChat. It's called WeChat.
Right,
yeah.
WeChat. Right.
Yeah.
So they developed it, and you somehow made it work for React Native.
Yes, I wrote the JSI bindings for it, and it's all C++. So it does not use the Java library or the JavaScript representative or whatever. It's just a C++ library exposed through JSI with synchronous bindings and as little overhead as possible. Yeah,
I found it to be really easy usable. I used it in one of my streams, especially. I mean, it comes with hooks, and so I could also just initialize my state with the values, and that just like, wow, it just felt amazing instead of like doing await async storage, get item something.
Thank you.
Just immediately getting the value. And you have this comparison also on the GitHub page. It's faster than, I mean, it makes sense. It just has to be the fastest option. The second one is actually, I think, Watermelon DB.
Yeah, they're also amazingly fast. But Watermelon DB is more focused on like storing more stuff. It's just MMKV fits a very specific niche where you just have small amounts of data that are either get or set really, really often or really fast.
And looking at that graph, is there actually an argument to be made for async storage? Like, it's in terms of performance, it looks like async storage is really, really bad, and we have either for a lot of data, SQLite, Watermelon, whatever, or for small chunks of data, MMKV. But why should we use async storage then?
I don't know. I mean, I don't want to, I don't want to say async storage is not used for anything. I'm sure there's a use case for it, but if you don't want to install two separate libraries, then you can just have async storage as a good hybrid middle ground for both. But yeah, for quick data, use MMKV, and for lots of data, use Quick SQLite, which is also a library by us now, or nice. Watermelon DB.
Yeah, makes sense. And also, MMKV can easily be used with state management. I used it in a stream as Zustand. So I don't know. I think, does it work with other state libraries as well?
Yeah, it works with. Let me just quickly pull up because I don't remember. Quickly pull up the README here. It works with Redux persist, recoil, mobx persist storage, mobx persist, Zustand, Yotai, and rec query.
Yeah, well, very popular. I assume so because the one common thing about all your open source stuff seems to be it's really well documented and it has a very clean API. I think you're putting a lot of effort into getting that right. So again, thank you for all you've done for the community.
Yeah, thank you. Yeah, I love API design. I think that's really cool to kind of abstract very complex things away into just very short and precise JS APIs.
Yeah, I watched a chunk of your previous live stream you had a few days ago before this recording, where you implemented the barcode scanner feature for the camera. And I thought, wow, yeah, he's really structured about what he's doing. And I usually just went straight into it. I think you probably had a better plan on what you want to accomplish. But I'm usually not that structured as you are.
Yeah, I mean, it has, I probably just have a lot of context because I developed the library. So I maybe have a mental mind map or something of the structure, how I want it to be exposed. And then also obviously you need to consider things like usability, flexibility, lean core, especially. I don't want to introduce a ton of new changes into Vision Camera that just make the development slower. I just want it to be very flexible and very lean but extensible. And then also, powerful and fast. So performance needs to be a primary concern as well. I don't want to build on some technology that's slow. I want, to be as little overhead as possible.
Right, and we have now dropped Vision Camera a few times during the stream. It's finally time to get into this. So I have used Expo Camera, and I have captured images, and I've taken images from the library. Why should Simon actually use Vision Camera instead?
So Simon should use the Vision Camera because, I think there's one argument to not use Vision Camera, and that would be if you're in an Expo Go app. And you just want to use the default camera that's available because you can't use any third-party native modules. If you are not in an Expo Go app, you might... I think there's 4 options. There's React Native Camera, which is deprecated now, so kind of not an option. There's React Native Camera Kit, which is originally by... Who was it originally? Was it Wix? I think Wix, and then now it's Tesla. Then there's Expo Camera by the Expo team, and React Native Vision Camera. So React Native Vision Camera is, the deal with Vision Camera is I have a lot of features and it's really fast and you have a ton of flexibility with the camera. So I think it's faster than all other cameras and has more features than all other cameras. But since it's just me maintaining the camera, I often don't really make sure it works on the previous 10 React Native versions. So most of the time there might be right now we have React Native 0.70, what is it? 3 released? Yeah, so Vision camera probably won't work on 0.69 because I just don't want to maintain like backwards compatibility for 5 versions or 4 versions, because that just slows down development, right? I can't just always focus on build issues. I need to focus on improving performance, fixing other bugs, making, adding new features, blah, blah, blah. So if you're somewhat up to date with React Native versions, I think it's fine to use React Native Vision Camera, or it's a good idea to use React Native Vision Camera, again, because many features, fast and everything. But if you're on an old React Native version, you might want to use something, that's compatible. Otherwise, you probably encounter some build errors or something that you need to fix yourself.
I mean, what you said in the beginning that I can't use it with Expo Go, just want to make clear, I can still use it with Expo if I just make a pre-build or a dev client build.
Yes.
Yeah. So I think if I have a use case where I want to develop application with camera usage and anything beyond just capturing or selecting an image, I think I need a different package, because the basic camera package only offers like take a photo or capture an image and maybe do like a little resizing or editing. But so many times people say, hey, I want to like put another button on the camera interface or anything like that. And I think none of that is possible with the other packages. And from what I hear, that should be easily possible with React Native Vision Camera.
Yeah, so I think there's a core, concept differentiation here. Like there's a camera component which you can use to render a camera inside your app, which is just a camera preview, and then anything else you just render on top of it. So it's just a normal view. You need to add a take photo button yourself because you need to call the take photo method yourself. That's a camera component like React Native Camera, React Native Camera Kit, React Native Vision Camera, and Expo Camera. And then there's a camera picker, which is just the iOS or Android default modal picker, which opens up and you can select a photo from your gallery or take a picture. And the take a picture function is, I think, an operating system default, like iOS or Android default camera view, which just doesn't have any options other than taking a picture. So this is not what Vision Camera is. Vision Camera is camera inside your app. And I think for every app, you probably want a camera inside your app, unless you don't really have time to develop it, because it's just a way better user experience to have something inside your app instead of opening a picker modal with way less features. It's also a bit slower, obviously, because it needs to slide up first and everything. So, and then, do you want to add anything on that?
So it's basically not just like from a mental model, not just a thing to pick an image, but it's actually like a stream of a video. I think on iOS, when I was an iOS developer back like a few years ago, is it like an AV capture session or something going on in the background?
Mm-hmm. Yeah.
Okay, so it's basically rendering what your camera sees, and then you can put all sorts of cool stuff on top of it.
Yes, exactly. So you have let's take a step back here. React Native Camera Kit, for example, as a current non-deprecated alternative to Vision Camera, does not support video capture, and they don't support like frame processing, and I don't think they support like exact device selection. Like, for example, I'm not sure if you can select the ultra wide angle or like the triple camera which is a virtual camera on your phone, so that you can smoothly zoom between, the wide angle or the fish eye camera.
I don't think so.
You don't think they have that, or you think they have that?
I don't think that they have that.
Yeah. I'm not sure if they have that, but that's also something that Vision Camera has. So Vision Camera has photo video capture. You can take a photo with some options like, I don't know, which photo codec you want to use, which file extension, which quality, like from 0 to 100. Then you can also enable depth capture, so that it also, with the RGB photo, you can also have depth data for portrait effects, for example, to only focus my face and the background is blurred. Then you have video capture as a second feature, which is like a recording session. On both iOS and Android, it's a fully custom recording session. So on Android, I use a custom OpenGL C++ pipeline for this instead of just a default recorder. And on iOS, I have a custom AV capture video data output delegate, long name. Just so for one specific feature, which is changing the device while you're recording. This is something that you don't normally have unless you create your own custom capture session, and that's really, really complex. So while recording, for example, on Instagram and Snapchat, you have that. While recording, you can flip the camera from back to front, right, and it still continues the recording properly. It still captures audio properly. It still has a correct orientation and buffer size, because the back camera might be 4K and the front camera might be 1080p. It still scales properly. Nice. So that's one thing that's really, really complex to do, especially on Android. And yeah, so that's something that Vision Camera has just out of the box. You don't need to do anything. You just by API design, you just pass a new device and the recording still continues. Then, since last week, Vision Camera also has a QR or barcode scanner, which you saw in the stream. And thanks for everyone who watched the stream. QR barcode scanner, which is the native platform barcode scanning APIs. And then on top of a barcode scanner, or at least separately to a barcode scanner, it also has a frame processing API, which is a bit complex. I think we should talk about this after I mentioned all the other features. So frame processors. Then you also have custom device selection. So if I have like an iPhone, I have the iPhone 15 now, you have 3 cameras on the back, and on this phone, you have actually 5 back cameras because you have 3 physical cameras you can select from. You can select this one, this one, this one. And you can also select the dual camera, which is combined of these 2, and the triple camera, which is combined of all 3 cameras. So combining cameras means you can zoom in and out of the between the cameras. So if I zoom to 1x zoom, which is the default, I'm just at the normal wide-angle camera. And if I zoom out to 0.5x, I'm at the fisheye ultra-wide-angle camera. So Vision Camera just natively supports that by using a device API where you can easily select any device you want, also using hooks. Then I'm not done. Then we have a formats API where you can select, because each camera device has a list of available formats. For example, the back camera can select or can record in 4K, 1080p, 720p, 480p, all other different sizes. And for each size, there's a different FPS range. So you can record, for example, in 4K, you can record up to 60 FPS. In 1080p, you can record up to 240 FPS. So those are all formats on a camera, and you can select those as well with a nice hook-based filtering API, where you just kind of describe your use case. So you just use the use camera format hook, and then you just say video resolution max, FPS 60. That's your target. And then you get a format that is actually filtered properly. So as said it just now, yes, you can customize resolution. You can record in 4K, 5K, whatever. And you can customize the FPS. You can record in 240 FPS in Vision Camera. Then we have, it's just optimized for performance. You can just easily, pause and resume as quickly as possible. You have HDR and night modes. And in V3, I actually worked on a Skia integration as well, so that inside of a frame processor, which I'm going to explain in a second, you could also draw stuff like, maybe filters like a sepia filter, or draw, a box around my face, and it's just perfectly synced with the preview, so the box is always there. Plus it's part of the recording. So if I record something, the box is in the recording. I did a prototype for that. It worked on both iOS and Android. I had an orientation issue on Android, and I just didn't record it to a file on iOS. And ultimately, I decided to just scrap all of that and remove it to a separate branch or separate fork. I'm still thinking about that, because it just overcomplicated the library a lot. And this is one of the most important things to me, that Vision Camera is a lean core, so that people who install it don't encounter if you just want to use Vision Camera for photo capture, just a very simple use case, you don't want it to fail to build because Skia is not working or something. That's not something that you want to do. So it should be very lean and very simple from the base, but extensible, that it's that you can basically do anything with it.
Yeah, this is just hearing you talk about all these features makes me want to build an application with it, because I'm looking at the preview on GitHub with like a cat and the screen, and you have some buttons rendered on top of it. And I sometimes have this case where I just want to build something because the library or the component looks so great, and this is definitely I'm pretty sure I'm going to make a stream about this, because I will implement something fun with it. Also, with your latest edition of the QR code scanner, you just basically made all the other barcode scanners obsolete, because you have to be the fastest scanner. Like,
yeah, sorry about that. Yeah, I just made the other barcode scanners kind of obsolete, but not like fully obsolete, because the other barcode scanners have stuff that this barcode scanner doesn't do. For example, maybe they have some native parsing going on where you can instantly parse a, I don't know, credit card or something and get the details parsed from native directly into JavaScript. Or that's also something that's possible in frame processors. They just use a different library, right? For example, on Android, I use ML right now. Maybe they use the zebra crossing library or some other native libraries. So, frame processors. This is actually a good point to talk about frame processors now.
Yeah, let's do that.
Okay, so frame processors are because if you take a look at a camera, I always use Snapchat or Instagram as a good example. And you move your camera, you have this preview view, which is just, showing you what the camera sees, right? That's how cameras work. You get a feed of images from the native camera, and the image itself, it always displays the latest image that's received from the hardware sensor. The hardware sensor is a camera device. So if you have a camera running at 30 FPS, you receive 30 images in, let's say 4K resolution per second. So
that's a lot of
30,
data.
30 times 4K images is, I think, 1.5 megabytes per second moving through your GPU. So after just it doesn't take long until you have a gigabyte of data streaming through. So what you need to do to make that as efficient as possible is to use the GPU, and you receive there is a way to get the a reference to the image buffer each time that your camera sees a new image buffer. So let's stick with that example. 30 FPS times, or 30 times a second you receive a new 4K image. I look at a cat and I want to be able to, detect cats. Let's say that's my app, right? I want to detect a cat in image. So what you need to do in this case, you need to receive the latest image from the camera and somehow get CPU access to that frame, because normally it would just be on the GPU, right? Because it needs to be fast. So you need to get CPU access to that frame, which holds the cat in it. And then I need to run some kind of algorithm, let's say a TensorFlow algorithm that are pre-trained or that are found in the internet, to detect and classify the image and see if there's a cat inside. This is TensorFlow normally works with, static images. So you have one image, like a cat, a photo of a cat.png or JPEG, and you just run your algorithm and it says, oh, there's a cat at X 120 and Y, 700 coordinate, To run this in real time, you need to be really, really fast. So what you need to do is you need to get a hold of this image, and this is what frame processors are actually for. Inside a frame processor, think about it like just a simple function that you have. It doesn't matter which environment we're in. If we're in native, in C++, or in JavaScript, you have a simple function that gets called for every new frame, and as a parameter, you have the frame. The parameter, the frame, is only valid for the time of the function, So if the function returns, a new frame might already come in. So the previous frame is no longer valid. We can't just stack up 1.5 megabytes in memory all the time. Sometimes it's going to explode. Yeah. So the previous frame is going to be deleted and the new frame is going to place on top, and your function is going to be called again. So 30 times a second, you receive a new frame, and you can theoretically access the pixels in that frame. So you can do, for example, get pixels, and then get the pixel at 0, 0 coordinate, so the top left pixel, and read that. So the way those TensorFlow libraries work is you convert the frame into a byte array and then just run the model on the byte array. Sometimes you need to resize the frame because we don't want to run it on a 4K frame. You resize it very, very small. So 480p or even smaller, 300 by 300. So that's usually the way you do that in a native app. You resize the frame, you have this callback, you run the TensorFlow model, and then you have your information. Is there a cat inside the frame or not? And frame processors, I just talked, it all makes sense in a second. Frame processors are simple JavaScript functions that use the same technology that I used in React Native MMKV, right? So they use JSI, which is the simple binding from JavaScript to C++, which is fully synchronous. So it is fully synchronous. You receive, when I receive the frame on my native side in C++, I call the JavaScript frame processor, and you have access to the frame in JavaScript. So that's a 1.5 megabyte frame you can directly access from JavaScript. which is quite impressive because it's not copying anything over. It's just giving you a reference to the fully native C++ frame, and you can do stuff like, I don't know, frame.width or frame.height or something like that. There's some examples on the Vision Camera website of a frame processor. So you can do frame.width, frame.height, and I don't know, do like a console.log. You're in JavaScript now, so you can do anything you want in JavaScript. You do a console.log of frame.width, and then 30 times a second, you're going to log, I don't know, 4K, for example, like 4096, I think. So now that you have a frame in JavaScript, you need to somehow call your TensorFlow model in JavaScript. And the way that works is either you pull a community plugin, some kind of frame processor community plugin, or you run a JavaScript model. But, JavaScript models are not really fast, so you want to use a community plugin or write your custom plugin, which is that's the only time you have to ever touch native code if you want to do this. A simple function called a frame processor plugin. And this function can be called from JavaScript again. So inside your frame processor, inside your JavaScript frame processor, instead of console.logging the frame.width, you just do like my native cat detector plugin, bracket open, frame, bracket closed. And then the my native cat detector, whatever I just called it, is a native function written in Objective-C for iOS or Swift, and Java or Kotlin for Android. And that's the only time you write native code. So this is like a simple function where you use the native TensorFlow library. It needs to be native because you want it to be fast, right? You can also do it in JavaScript using like JS libraries, but it's going to be slow. So on the native side, you can use GPU acceleration and everything. It's, for most cases, probably just like 10 to 20 lines of native code you need to write. And then you have a fully, a completely, like a really powerful real-time cat detector. You don't need to write any camera code, and you don't need to worry about memory or anything at all. You just have this simple frame processor plugin that runs on every frame.
This
lots
is
of information.
Yeah, a lot of information, and it's also mind-blowing how smooth the experience actually is. Like, we still need to remember we're in a cross-platform environment. What React Native is, but what's possible here is like really mind-blowing. And once again, I had some ideas while I talked about this, and just this, like having the power to receive the stream of video you capture, and then just like, yeah, the sky's the limit. You can do whatever. You can just draw like a black box somewhere on the screen because you don't want to show that area. Like I was thinking about security cameras, or
blur faces, for example. You can run a blur overlay.
Right. Yeah. Or draw something on the face, like in all popular Instagram or Snapchat or whatever TikTok videos where you have like something on your head. All of that should be possible, and all of that is possible. And I saw you also created I don't know if you created this recently, the React Native Fast TF Lite package. Does that fit into the picture of the frame processing?
Exactly. So previously I mentioned, if you want to write, for example, a cat detector, you would need to install Vision Camera, write your JavaScript code, which is really simple, right? You don't need to worry about camera setup or like real-time streaming. You just need to install it in JavaScript and then write the simple native function to load a TensorFlow model. And some people don't want to touch native code at all, So I built React Native Fast TF Lite, which is a plugin for React Native and for Vision Camera. So it works in Vision Camera as well as in just bare React Native. So you can actually load any kind of TF Lite model which is inside your JavaScript bundle, right? You just drag and drop it into your assets folder. It's a .tf Lite model, and you can just call that with the frame. So no native code at all. The only thing you need to worry about is resizing the frame properly, because that's not something Fast TF Lite should do, and I don't think that's something that Vision Camera should do. Maybe TF Lite should do it actually, but you can call it essentially. I don't know, if you find a cat detector .tf Lite model, you just install Vision Camera, use Vision Camera, drag the TF Lite model into your assets folder, install React Native Fast TF Lite, and then load the model and call it. That's it. No native code at all. It uses GPU acceleration if possible. It's a C++, again, JSI library. It's really, really fast, but you just need to make sure that you resize the frame properly.
So is it complicated to resize the frame? Because you said it a few times now. Like, it sounds like challenging. If you say it a few times, I assume it's not like 3 lines of convert frame equal to 400 times 400.
No, so unfortunately it's not that easy if you want it to be fast. So if you want to resize a frame really fast, I started writing a resize plugin for a Vision
I
camera.
was expecting this.
So it's called Vision Camera Resize plugin, but I didn't finish it yet. So it's just like the code is there for iOS, but it's not there for Android yet. So the way you would resize it on native would be, or really efficiently resize it on native would be to use Accelerate or vimage, is it called? It's basically a CPU vector optimized resizing library similar to OpenCV, for example, where you just receive a frame, or where you pass a frame to it, and then it really, really fast resizes the frame, scales it down, creates a new buffer, blah, blah, blah. So you just need, actually the buffer creation is on you, so you need to create a buffer in advance and then resize it into the buffer. So there's 3 steps to it, buffer creation, resizing, and cropping. And yeah, that's really fast. So I managed to do that in, I think, 2 milliseconds from 4K to a 300 by 300 image, which is really fast, right? 3 or 2 milliseconds or something like that is really, really fast in debug. So that's really fast on iOS, but it's a lot of code. On Android, you would use OpenCV for that, which is in C++, I think. I'm not sure if they have a Java library. So that's also probably the same thing as on iOS. It's a little bit of code you need to write, but it's possible to do it really fast. And then you can also, as a slow alternative, you can also do it in JS. And I have an example of that on my blog post, actually, the latest blog post detection using Vision Camera V3, where you just get, because you actually have access to the byte array buffer in JavaScript of the frame. And you can just use normal math or I guess for loops to just resize the buffer. This is also possible, but it's obviously really slow because it's running in JavaScript. So I think the resize from a 4K frame to a 300 by 300 frame in JavaScript took 16 milliseconds. I mean, it is, okay. You can still run at 30 FPS, which is quite impressive, right? Resizing in JavaScript at 30 FPS. Indeed. But it's, I wouldn't do it. I would write a simple native plugin for that, or, wait for me until I publish my resize plugin. But yeah.
Yeah, I've seen that. Do I always have to resize it? Or if I, let's say, I want to draw the banana on the screen or just make, I don't know, a static area black, do I need to resize it for those use cases as well, or is resizing only necessary if I want to paste or put the frames to the ML library?
It's only for ML libraries, so it depends on the ML library again. For example, if you use MLKit, you don't need to do any resizing at all. You just pass it to MLKit, and MLKit under the hood, they probably do exactly what I just said. I'm not sure. I think they do. They use Accelerate and OpenCV, or have some custom resize code for it, because under the hood they're also just using some trained models. So in this case, you don't need to resize it. But if you're just using bare TensorFlow models, they expect a very specific buffer length, and they expect you to just resize it exactly into the buffer length. So it's your responsibility to sanitize the input in TensorFlow Lite. In some other ML libraries, you don't need to do that. And if you just want to draw something using the Skia integration that's not yet in Vision Camera, then you also don't need to resize anything, because resizing is only for sanitizing input for ML models.
This is all really, really epic. And I mean, probably the most epic thing about all of this is that it all is free. It's just free. I can just use it on GitHub, and you've probably spent I don't know, 1,000 hours on this.
More.
You've been working, more.
Yeah.
Yeah, and we can just use it completely for free. How's that possible, actually? Wow.
I don't know. I mean, I started working on Vision Camera when I was working for a startup, and then I just had a passion for it. So it was really interesting to me, and that's why I made it open source and just continued to develop it. I have a few sponsors on GitHub, so huge shout out to all my sponsors here. If you support me on GitHub, I love you. There's a few people, even just persons, not companies, who are sponsoring me for 20 or 50 a month, which is motivating me to continue spending time on improving Vision Camera, and obviously I prioritize their issues over all other issues. But yeah, I think in general, the reason why it's working, the reason why it's on open source or on GitHub, and for everyone to use is because there's some people who are really glad that I did it. I also want to kind of show off here and just say, I built this. It's pretty amazing. You can use it if you want. And I think it's just kind of cool to share that. And I guess the reason why I'm not, open source is always like a struggle for some people, right? So I think the reason, or the way I made it work is I just simply ignore any issues that are not well written, or people who expect like a huge change from me without any like payment or something. So if someone is going to create an issue and they're like, we need, I don't know, a cat detector plugin in Vision Camera, I'm going to say, no, that's not part of Vision Camera. I can create a separate plugin though. And they're like, yeah, you need to create a separate plugin. And I'm like, pay me, because I'm not just doing anything for free. But yeah, if like some other people just have some bug reports, they're like, we use Vision Camera, it's great. We sponsor, I don't know, 50 a month for the development, and we have one bug report a month. Then I'm just going to focus on that and fix that for them, as a kind of gratitude as well. But yeah, you need to find a balance between, what you prioritize and what not.
You currently have 59 open issues. I think that's pretty good for an open source library. I've seen other packages, community package with way more, so I think you're quite good with that. You also have
I had 200 plus open issues a while ago. So I went through every issue and tried to figure out, was it fixed already? Is it a stale issue? Did I fix it with the Vision Camera V3 rewrite, which is a huge change, by the way. So if you only tried Vision Camera V2, you need to try Vision Camera V3. It's like a almost completely different thing. So yeah, I closed a ton of issues. So now I'm down to 59. There's, I think, 2 major bugs right now and 1 build error. So on Android, for some reason, it does not build on React Native 0.70. And I don't know. I mean, it's an older version, but I still want to fix that. And then 2 bugs where some Samsung devices don't, or just show a black screen, which sucks because it's only Samsung and maybe some other weird phones. So it's just Android camera APIs that suck. And then 1 other where, I don't know, there's a crash in certain scenarios. But yeah, majority are like, some feature requests or some edge case things. Overall, I would say it's pretty stable.
Yeah, that's good to know. And yeah, I will definitely use it. And we're running a bit out of time because I still want to touch 2 other topics quickly. So
let's do
before
that.
we wrap it up, on React Native Vision Camera, you are currently at version 3.30, I think, or 3.31.
Yeah.
Have you already plans for V4, or what are like for the next, let's say 6 months, the next steps for Vision Camera, the next bigger things you want to implement?
I don't have any plans for V4. So V4, I don't know if there's anything really groundbreaking that you could add there. Maybe it's going to be the Skia integration. Who knows? Maybe V4 is going to allow you to draw back onto the frame, onto the recording, and onto a photo in real time fully synchronously. Right now, that's not on the horizon. Right now, I just want to make sure Vision Camera V3 is as stable as possible. We have a fully rewritten code base since V2. I now use Camera 2, the low-level Android camera API. Want to make sure that's like as solid as possible, as fast as possible, and working on pretty much every device. So that's why I need, the community to give me feedback and to give me well-written, structured bug reports. So yeah, that's a goal for, I think, version 3.4, like a really stable foundation. And then for V4, maybe, Skia. But I don't know. I think other than that, Vision Camera can do everything that a camera can do, as of today.
I mean, you've been working for it for how long? A few years by now?
Yeah, I think, 3 years, maybe 2 or 3 years.
Yeah.
I think 3 years.
So maybe it's somewhat feature complete at some point.
Yeah. Yeah, I mean, people often underestimate how much time goes into it. I don't want to go into much detail here, but it's, you're dealing with a hardware sensor, right? There's like 1.5 megabytes buffers going through the GPU, so you need to know about hardware stuff. You need to know about iOS native development, obviously. You need to know about GPU stuff, about memory allocations, about performance, about, there's so many things that you need to worry about. It touches on cameras, lighting, ISO values, exposure, then OpenGL, graphics, drawing, rendering, 60 FPS versus 120 FPS, making sure it's synchronized, locking, blah, blah, blah. Zooming needs to be really quick. It's just a lot of stuff that you need to think about.
Yeah, it was interesting to see you in the stream jump from TypeScript to Objective-C to Kotlin. I think like having these powers, it's kind of a superpower. If you want to develop React Native applications, you don't have to know about Kotlin and Swift or Objective-C to get started. Like, you can still build great applications, but just having a bit of understanding about the APIs and what's going on, and not being scared to like get into some Swift or Kotlin can definitely be helpful if you want to implement something challenging.
Yeah, I mean, as always, the better you understand an abstraction, the better you are at using it, I guess.
So this is an Epic library, and part of why you have time for it is probably that you also use it for your clients at Margelo, I just assume. What was probably the most impressive thing you did with Vision Camera at Margelo, just to give like the listeners an idea of what's possible with Vision Camera?
So we did a few things with Vision Camera already. I'm going to not go into too much detail, but we did a document scanner with Vision Camera before. So you just took a picture, or in real time it detected a document laying on the table in front of you, which could be an invoice or some other document. So it actually scanned that using a native API or a native plugin actually, but it used all Vision Camera for it. Then we used Vision Camera for a face detector and filter API. So we actually had like a pirate hat, for example. This is on our website, margelo.io. We have a plugin with some other it does use a separate rendering layer, so there's a small difference here, but it is based on Vision Camera, and you actually have a pirate hat projected onto your head, and it's in real time, 60 FPS. Everything is working as smooth as Instagram or or Snapchat. So yeah, face filters, document scanner. We also did like a 3D scanning app, which uses depth capture to scan your room into a 3D model. This also is based on Vision Camera, but it is a custom fork which just streams the depth data. This is not part of Vision Camera main right now, but it's not a lot of changes. So I think it's just like 2 more commits to just enable the depth capture streaming and synchronize it. This is something we did. Maybe before. And then what else did we do? A VHS filter for a client, where it's just like a VHS old school recorder thing with the like overlay here, a bit pixelated, and these like vertical lines and everything. So pretty cool filters. And then what else? Yeah, just some basic photo functionality, video functionality as always. And then there's one cool app which we did not work on, but I'm talking to the guy all the time. His name is Manuel. They're working on, what is it, Unbogify, I think it's called, which is like a golf swing detector. So you put the phone in front of you, you do a golf swing, it records at 240 FPS, uses Vision Camera, and it tells you how well your golf swing was. So it uses analyzing models and everything. So it's pretty amazing what you can build with Vision Camera. Yeah.
As I said already, it's just too awesome to not use it. I will have to think later today about use cases because I'm looking for a new side project, and I like a lot of possibilities that you could do with a Vision Camera. So I don't know, something with slow motion or so, because you're capturing so many frames should be possible as well. So interesting. Is this like the golf swing the most popular application, or are there? Do you know about other popular applications using Vision Camera? Like
so the problem is the problem is that the people or corporations who use Vision Camera often don't reach out to me to tell me we use Vision Camera in our app, thank you for it. They just don't reach out, which kind of sucks, because I really want to know who uses Vision Camera. I just know of a few. So I know that Locket, the app where you can see a picture of your partner on your home screen, uses Vision Camera or used Vision Camera. I'm not sure if they still use it, but I just know that they did use it. Then this is actually pretty popular. So I think Locket has many downloads. I know that Discord forked Vision Camera at some point. I don't know if they use Vision Camera or are inspired by Vision Camera or use a fork of Vision Camera in their app. I don't know, but they did fork it. Who else? Expensify is a pretty big app. It's open source. They use Vision Camera. What else? Yeah, Unbogify. I don't know about many other apps that use it. I think you can see like the open source projects on GitHub. If you open the like used by tab of Vision Camera, I can just quickly tell you where's the number?
Used by. Never saw that
used by
tab.
2.4K open source repositories use Vision Camera.
Oh yeah. Okay, so everyone else who's using it in open source, that's easy to track then.
Yeah, but it's, most of the apps aren't open source, so this is just like test apps, or some open source crypto apps actually use it. I saw that before, but yeah.
Yeah. That's great. I mean, it's epic. I'm going to put it in the show links, and people who listen to this will, I swear, they will see me on a stream using it in the next couple of weeks when I got time to figure it out. So the last thing I want to ask you today, because we're really running out of time, I think the last episode I recorded was the longest. Probably this one is now the same length. I found on GitHub, I'm the master detective of finding the small hints. On your GitHub sponsor page, the last sentence somewhere was, you will work on the upcoming wishlist project. So, what is the upcoming wishlist project? Is it the final solution to lists in React Native, or is it something completely different?
So I was actually about to do an announcement or like a statement rather on public Twitter, because lots of people are waiting for it. Wishlist is not the magical solution to lists, unfortunately, in React Native. It is by design, or with current technology that we have, not possible to build a magic solution for a asynchronous rendering framework. And React Native is an asynchronous rendering framework. Same as Texture, or also called async display kit, or I don't know if Flutter is actually sync or async, but it is not possible to sync or to build a really fast recycling or visualization list using an async framework. So what you need to do is either use a template-based approach, which is what Wishlist is kind of doing, or kind of figure out how to render from two threads at the same time, which is a very bad idea. Do not do this. This is why UIKit has limitations where you cannot access their UI APIs from a background thread. So only solution one is actually viable for an async renderer. You create templates. You tell the list how you can render this, and then the list renders it really, really fast using a template-based approach. The problem with this is how Wishlist works today. The problem with this is that you're very limited. You cannot use stuff like, I don't know, React Native gesture handler anymore. We have to write custom bindings for that. You cannot have use state in your items anymore. You have to lift the state up and then inject it into your data. This is actually a good performance recommendation anyways, so I don't consider this a limitation, because it's just better to not use state in your list items, but instead lift it up to the data. But again, you're pretty limited there. So it is unfortunately not a magical solution or perfect solution for everything. It is a good solution for when you can use template approaches. Because again, the templates approach with simpler list components, you're not like rendering really advanced stuff in your list components, then it is a good solution, and it's fast. It's as fast as native, I would say. So it's really it's insanely fast.
And I'm sorry, I don't know a lot about Wishlist yet, but in how far is it different from like Flatlist and Flashlist? Because I thought Flashlist was already the solution to have performant lists.
Yeah, no, so Flashlist is a very good solution, but it still uses the asynchronous rendering approach, right? So you have your view, you render it, and then it sometimes at a later point goes to the UI thread where it gets rendered. Wishlist is a new native list component, because, fun fact, all of the lists that we currently have in React Native are one single native component. They're all based on RCT scroll view, and then derived from that is virtualized list, derived from virtualized list is flat list, and then derived from, I think, flat list or virtualized list is flash list again, and recycler list view is also derived from virtualized list. So it's all just using RCT scroll view. There's no other native component. All of the magic is happening in JavaScript. So Wishlist is a fully new native component, where all the virtualization and recycling is happening in Yoga, in C++, we're dealing with the shadow nodes and everything. So in theory, it should also be faster there, because we're at the single source of truth of our layouts. But again, it is just very limiting. So that's the only reason why we haven't published it yet, is because we have so many limits here. You can't really use state or anything. It's all just worklets rendering your templates.
Will you still publish it, or will you keep it internally at Margelo?
I might publish it soon, maybe.
Okay, that's an answer.
Yeah.
All right, so we'll be looking out for a statement at Margelo or at your account. That's a nice place to wrap up. So where can people find out more about you and your work?
A good place to follow me is Twitter. So on Twitter at @mrousavy, you can follow me. I tweet random stuff there, tweet updates about libraries. I tweet some random fun facts, some performance tips and everything. So if you don't follow me on Twitter, follow me now. Also follow Margelo at Margelo_IO on Twitter. And yeah, I think those are the 2 places where we tweet really interesting content.
Awesome. Yeah, I just followed Margelo as well. So thanks for taking the time today and explaining your packages. And of course, thanks for creating them in the first place. You will definitely see me put them to use over the next time. If you want to check out more about me and perhaps learn the basics before we get into React Native Vision Camera, check out galaxies.dev, where I have tons of courses on learning React Native. And once you get the basics right, you can dive into MMKV, which is actually part of one of the courses, I think, because I really enjoyed it with Zustand. And of course, React Native Vision Camera. So thanks again, Marc, and hope to catch you again in the future.
Yeah, thanks for having me. And let me know when you do those streams or episodes. I want to maybe join there and give some tips about Vision Camera usage.
Thanks, I will do. Thanks. Bye.
Ciao.